In this video we're going to talk about bearings. A few key things to remember about bearings. They are always measured from the north. So we want to keep that in mind. Remember, north is pointing up your page. So at any point you measure the bearing from the north. For instance, the bearing for point A would be from the north to A. The bearing for point B would be from the north all the way around to B. And for C it would be from the north all the way around to C. So always from the north point you measure all three of them. And they're usually written with 3 digits. If it's less than 100, like 18 degrees for instance, we would write it as 0.18, or 113 degrees, or 92 degrees would be written as 0.092 degrees. An angle like 320 would be just 320 degrees. And it's also sometimes helpful to remember your parallel line rules, i.e. alternate angles are equal, corresponding angles are equal. You can use co-interior angles as well. Other key things to remember would be just a basic reminder about our coordinate grids. Never eat soggy Wheat Bix, and remember that it's 90 degrees between each of these. So in this case, angle A is going to be less than 90 degrees because it's above the east if you were to draw it in there. And angle B would be more than 90 degrees. This would be 180, and that would be 270. Alright, let's take a look at an actual problem. So this is an orienteering course. The course starts at the start, and the individuals run to the northeast. So that's in this direction out here to point A, and they run for 750 meters. At A they turn northwest for 550 meters. And then from B they return back to the start. So from B we can actually complete the diagram. They return back to the start. Now that's all the information they've given us, and they want us to find the distance between B and the start. And they want us to find a bearing from B to the start. So one thing that comes up frequently for us in bearing problems is that they'll try to give us a hint about finding a 90 degree in there so we can use Pythagoras. The transition from northeast to northwest, from northeast to northwest, is actually 90 degrees. So that's what they're talking about here. This angle that they turn at point A is actually 90 degrees, and now we have a right angle triangle. So for part 1, finding the distance between B and the start, well, we've got a right angle triangle, and we know both of the short sides, and in this case we're looking for the long side. So I'll use my Pythagoras formula in the form of C is equal to square root of A squared plus B squared, knowing that C is the long side and A and B would be the short sides. So in this case, C is equal to 750 squared plus 550 squared, all under a square root sign. And our answer for this one, plugging it into our calculator, and we will get roughly 930 meters from start to B, or from B to the start. Direction doesn't matter on that. Okay, so we know that this side of the triangle then is 930. For part 2, find the distance between B and find the bearing from B to the start. So in this case we haven't been given any directions yet on the diagram. So the first thing that we need to do is actually draw in our north line, because bearings are always measured from the north. And we have to figure out where to put it. They want the bearing from B to the start. So this is the point that we'll draw on our north, because that's where it's coming from, so that's where we need to measure it from. So we're going to draw a line straight up, and that's our north, and again we're drawing it at the B because that's where we're starting. And we've got to measure the bearing. Remember, that's from the north, so from the north all the way around to where it would hit the line to head back to the start. That's the bearing that we're looking for. So how do we go about solving this? Well, let's take a look. So in this problem, it's going to be helpful for us to remember about our coordinates as well. So just sketch them in up here again. Never eat soggy Weet-Bix. And then we've got these angles in here, the northeast and the northwest that they've used. So northwest is actually splitting the 90 degree there exactly in half. So the angle between north and the northwest is actually going to be 45 degrees. So if we want to draw on a north here, on A, again, splitting between north and west, we have a 90 degree angle between those two, but splitting it down the middle on the northwest is actually going to be a 45 degree angle. So we know that this is a 45 degree angle in there. And if you pay attention to it, these two red lines, what do they actually make here? Both of them are pointing north, so they're actually parallel. Those two lines are parallel, and we have co-interior angles. So the angle from N to B to A here, I'll highlight that in yellow, is actually going to be a co-interior angle with 45. So it's 180 degrees minus 45 equals 135 degrees. And our reasoning for that would be that co-interior angles equal 180 on parallel lines. So that's a little bit of information for us, so we'll go ahead and write that in as well. This bit here is 135. Again, co-interior angle there. So that provides us with a little bit of information. The next thing that we're going to want to do is actually possibly figure out how big this angle is, this part of it. Because if we know the yellow and we know the purple, or the pink, we'll actually know that bearing that we're looking for. So how could we find this purple angle in here? What could we do? In this case, the angle, we could call it from start to B to A, so angle SBA is actually part of a right angle triangle, so we can use tangent, cosine, etc. to find it. And we know these two sides here. We also know that this is 930, so possibly let's use a tangent function. So tangent inverse for tangent is TOA. And if we're looking for the angle, we need to cover that part up and use the inverse function. So opposite, being 750, all over 550, in brackets, gives us the angle of 53.7 degrees. So inside of here, we've got 53.7 degrees. So our bearing that we're looking for from B to the start is just going to be adding up the 135 there and the 53.7. So 135 plus 53.7 is equal to, we'll round it, 198 degrees. And that is the actual bearing, so that is our final answer. Again, going from B, so we've got the north off of B, that's how far you'd have to turn around to head in the direction of the start again, be 189 degrees. And here we had to use our co-interior angles, as well as these ideas about our coordinate axes and the 90 degrees and 45 degrees between all the different north, northwest, south, southwest, etc. So we'll take a look at a second example here. The bearing of A from C is equal to 130 degrees. So this has been given to us. So the bearing of A from C. So of A from C. So where we come from is where we want to put the north always. So wherever you're coming from is where you want to draw on that north. So from C, we'll put a north. And the bearing from C of A, or of A from C, so back around to A, that one there, is 130 degrees. and the angle CAB down here is 65 degrees. And they want us to find the bearing of A from B. So from B to A, it's going to be that one there. That's what we're looking for. Okay, so this is what they've given us, what we've got for a start. Let's see what we can piece together. Remember, we do have parallel lines here with the two norths that are drawn on there. Let's see what else we can get out of this. We do not, in this case, have a 90-degree triangle given to us, so we cannot assume that. Therefore, we can't use Pythagoras or trigonometry. What other tricks do we have? What happens if we kind of dot this red line, this north line, straight down? That makes a straight line for us. And how many degrees on a straight line? There are 180 on a straight line, so what size does that make this? That angle there is 50 degrees. Again, that's 180 minus 130 equals 50 degrees. And that's because angles on a straight line equal 180. So we know that that is 50. Now, if we do another north here on A, we realize that we've got parallel lines, and we actually have a Z angle in here, an alternate angle. I'll draw on the Z so you can see what I'm talking about. Remember, the two little elbows of the Z are going to be the same angle, so in fact, we can see that this part is 50 degrees here. So if this part of the angle is only 50 degrees, how much is this part over here, the other part, the other half of it? Put it in blue. Well, that's going to be 65 minus 50 is equal to 15 degrees. And well, we're just adding those up, so no geometric reason for it, really. But pay attention here. We now have co-interior angles. We also have alternate angles, potentially. So I'll use a different color this time. Let's dot this north line straight down. And if I draw in a Z angle here, we'll notice that in fact this is 15 degrees as well as this being 15 degrees. Oops. So we've got part of our bearing. We know from straight down from north over to the A is going to be a total of 15 degrees here. But now we've got to remind ourselves how much the rest of this is. So in our coordinal points here, from north to south is 180 degrees. So our bearing from B to A is going to be equal to 180 degrees plus 15 degrees. In this case, adding up to 195 degrees as a bearing. Again, that's the 180 degrees from the north to the south, and then that little bit more of 15 degrees that we found using alternate angles that carries us all the way around, going from B down to A. So those are two problems for you to do with the bearings. Again, remember,